everyone. Welcome to Summer Sensor Storage. We are so excited. This is actually our second time around. We did this webinar last year and it was such a success that we're doing it again this year. So we are so excited to kind of show you all of our amazing tips and tricks. Now, while everyone's getting settled into the Zoom room, I would love to encourage you to go ahead and navigate to the bottom of your Zoom window and click that little chat bubble. And let me know, are you done with school? Are you nearing the finish line? How's everyone doing? And just make sure when you put your comment into the chat, go ahead and set it to send to everyone. You'll want to have that setting on during the webinar. Our fantastic presenters will be answering questions as the webinar goes on, and you want to make sure that that is set to everyone so they don't look like they're just talking to themselves, and that way everyone can read your questions. It looks like some folks are finished with school. Congratulations. Oh, we've got folks working on research. That's awesome. Exams next week. You've got this. 2 more days. Oh my gosh. The finish line is in, right there. 1 more day of exams. Today is the last day. Oh my gosh, fun. Congratulations.
Oh, Teresa's here. Hi, Teresa.
I was about to say, I recognize the name there.
Hi.
That's awesome. Well, to make the most of our time together today, let's go ahead and jump to the housekeeping. Really just 2 important things that I want you all to take away today before I hand you over to our lovely presenters. First and foremost, a recording of this webinar will be live on both our website and our YouTube channel. They are linked right there, and I'll get you the links here in a moment. It typically takes about 3 to 5 business days for that to be edited and uploaded. But as soon as that is live, you will also receive a recording of today's webinar. So keep an eye on your inbox. It is coming your way, and you will also have a link to the resources folder. I'm going to go ahead and drop that in the chat box as soon as I'm done talking. In there, you can find a certificate of attendance. If any of you are using this for PD, you can also follow along the presentation and click any of the clickable links in there. So I'll go ahead and drop it in there. We're going to try to answer all of your questions, but if we happen to not get to your question or you think of something later, please feel free to reach out to us. You can reach us at biology@vernier.com or chemistry@vernier.com, depending on what you're interested in. With that, I will pass you off to our presenters, and thank you again for joining us.
Hi, everyone. I'm Melissa, and I'm joined with Colleen. So I will let Colleen introduce herself.
Hi, everybody. I'm Colleen. I'm a biology and environmental science specialist here at Vernier. I've been here for going on almost 11 years now. And before this Vernier life, I used to teach in Houston, Texas, where I taught high school biology and AP environmental science. Melissa.
Yes. Hi, everyone. I'm Melissa. I am one of the chemists here at Vernier, and I've been at Vernier now almost 14 years. And before that, I taught chemistry at the college level. And now both Colleen and I do a lot of these trainings, and we talk to customers a lot, and we also are pretty involved in product development. So we are going to tell you all about how to store your sensors and even a little bit of troubleshooting along the way. So it's the end of the year, just like everyone was alluding to in the chat. Some of you are already done. Some of you are done in the next week or month. So now is a perfect time to take a look at all of those sensors and store them properly so you don't have a whole bunch of issues when you come back in the fall. And then, so we're going to basically just go through all that, storing them, checking them, tips and tricks, and how like the repairs process kind of works at Vernier as well if you do need to send some things into repair. I do recommend once Dylan puts, I don't know if she's done it yet, the Google folder that has this slide deck in it. It also has a sheet with some resources, but I highly recommend, there's a lot of links in this slide deck. So if you want to follow along and click on them to see your particular sensors, there's videos, there's all kinds of stuff. So I recommend going to that Google folder. All right, so let's get started right out of the gate with pH sensors and ORP sensors. This is probably the #1 question we get about storage and troubleshooting and maintenance. I made a little flow chart here for everyone because I find it really helpful when I'm helping teachers troubleshoot their sensors. And so hopefully you will find it helpful as well. So starting off, you get out your pH probes, and this is true whether you have a cabled pH sensor or the Go Direct sensors. It's true whether you have a flat pH or a ORP sensor, any version of our pH probes. And it's true for like a lot of pH probes out on the market, just not only ours, because a lot of pH probes work the same way. So first off, when you go to put your pH probe away, you want to make sure that it has this storage solution bottle on it, and that storage solution is full and translucent. If there's not a storage solution bottle there at all, and it has been stored dry for you don't know how long, since the last time you did a pH experiment, we do have a method for shocking the pH electrode and reviving it. So if you, how these links work, you should just be able to click on them. And most of them are taking you to an FAQ on our website. We call them TILs, Technical Information Library. And they usually just have these really helpful tips. So this will tell you how to shock your pH probe and test it to see if it's still working. So that's what all the links do in the slide deck here. So the next thing, if it's in the solution and the solution's full, but if it's not translucent, you want to dump out all that solution and clean it out pretty well with some mild detergent. Usually what happens is it grows mold. And so you'll actually see the dark colors. It'll either be all mucky and cloudy, or it'll have little dark spots from the mold. Just dump it out, goes down the sink, rinse it, mild detergent. Make sure you rinse the tip of the electrode really well, especially if you have the rounded bulb kind. Just do like a gentle brush or get a squirt bottle in there. You don't want to rub it too hard because it is a glass bulb. So just be pretty gentle with it. But then you're going to fill this. You want to refill this bottle after you've dumped out all the mold and cleaned it out pretty thoroughly with pH storage solution. We sell pH storage solution, but we also have recipes for it on our website. Essentially what it is a pH 4 buffer with a little bit of potassium chloride in it to keep the ionic strength of your electrode solid. And then it also has a couple drops of mold inhibitor. If you're making it yourself, you probably won't have access to the mold inhibitor. Flynn sells a nice little dropper bottle of it, so you can buy one of those. Or you would just maybe need to replace it more often if you don't include the mold inhibitor. All right, so that is the storage solution that goes in the bottle. The next thing you want to make sure before you put your pH probe in the storage solution and put it in a drawer is actually inspecting the bulb, making sure it's still intact. It is not worth storing that pH probe properly or calibrating it or trying to get it to work if the bulb is broken or has a big crack in it, because it will not work properly. So that is just, you need to throw it away and replace it. Replacements with the Go Direct are really nice because you just have to purchase the electrode portion, and you just buy this part separately, and then you plug it back into your electrode amplifier. We do have options like that for the cabled version. Let us know if you want that, but we're going to keep going down the flow chart. So assuming your bulb is intact and now it's in clean, fresh storage solution, and if I want to put it away, making sure it's like in the ballpark of usable when I take it out. So maybe we're taking out for some summer research projects in a couple of weeks, and I don't want to have to like do all my troubleshooting then. You just want to connect it really quick to the software and see if it reads somewhere between pH 3 and pH 5 in that storage solution. If it does, store it relatively upright. It doesn't have to be fully upright. We've had some teachers get really creative. You can see here and make their own little storage upright racks. There are some like kind of conical tube racks you can purchase on Amazon that hold these upright nicely. We want to avoid throwing them all in a drawer, because then some of them will be like this and some of them will be like this, and you won't really know. If you have a drawer that has like slots and it's tilted a little, that's fine. You just want to make sure that the bulb is in the liquid. So calibrate it when you get back to school. Okay. Don't worry about calibrating it for storage. If it's not reading between pH 3 and pH 5 in its storage solution, I do recommend calibrating at that point just to see if it can hold a calibration, because if it can't, it might not be worth storing, or you need to call us and see if you need to send it in for repair. And then you might as well get those repairs done while you're at summer vacation. And we have videos here that show you how to calibrate your pH probe. There's instructions in the user manuals, and there's FAQs on our website as well. So there's lots of links to calibrating pH probes, whether you have the wired or the wireless. The procedure is a little bit different. So kind of just to quickly talk about lifetime expectations. Some people think pH probes will last 20 years. Sometimes they do. That is not very often. And that would require a lot, like calibrating constantly, I would expect.
It's a magical pH probe if it
That's
lasts
magic.
20 years.
Yes. Yes. 10 years is even on the stretch. And I've seen more last 10 years. I don't know that I've seen any last 20 years. But typically we say with proper storage and calibration, they will last around 6 to 8 years. We warranty them for 5. So you should always be able to call and walk through some of these troubleshooting steps with us. But when they're old and they no longer calibrate, then you really do just need to replace them, or if the bulb is broken. So those are kind of the setting the expectations up for the pH probe. And that's this, again, the same for ORP and all our pH probes. All right, so again, we have videos in here that show you how to do the calibration. And we have a webinar that was kind of specifically around pH sensor care and feeding. So if you really want to get all the details about pH probes, I highly recommend going to that webinar and watching that. Oh, one other thing I do want to mention, when you go to calibrate, if you bring them out in the fall or next month for your summer research project, you can store calibrations to the sensor. With the Go Direct, they store automatically. With the cabled sensors, you have to do another step in software, but all of that is shown in those videos. So don't think you have to calibrate them every time you use them. You can store that calibration. And storing a calibration should last quite a while, especially if it's a well-maintained pH probe. But once you start to see, data that doesn't look good, or again, if that pH storage solution is outside the 3 to 5 range, you need to recalibrate and give it another go. All right, so that was pH. Again, make sure you're putting any and all questions into the chat box. Colleen will interrupt me if something good comes up, but other than that, we're going to move right on to ISEs. So ISEs are another electrode that we have that requires maintenance and upkeep. So before you go to store them, one thing that is really, really important to keep in mind is that ISEs have a shelf life whether you use them or not. And the end of the part that you put into the solution has a module on it. that you unscrew that module, and that is the part that you replace that has the shelf life. Oh, you know why I can't unscrew it? Because it's a chloride ion selective electrode. Chloride does not have a module. So if your chloride ISE is giving you some weird data, you just take a polishing strip and rub the edge of it till the data looks better. So when you unscrew the tip, so if there was a module here, I would just unscrew this. And then it looks like this picture right here on the slide deck. And on that module has a date code. And so it'll say the month and year. So like November 2018. That means that that module was manufactured in November of 2018. The modules typically last 2 to 3 years before they need to be replaced. So if I pulled out a module that said 2018 and it's 2024, I would say that's a 6-year-old module. And that's probably why my data is funky. So I should probably replace this module. And it's good to do that before you store it, because then you have to order one and it takes, a couple weeks for us to get it to you. So we like you to look at that, more than the day before you want to use it. Then if the module is within 2 to 3 years, you're getting good data with it, you didn't have any problems, it doesn't have that sticky note that says doesn't work on it, you just make sure that you wet there's a sponge that comes in the storage solution bottle or storage bottle, and you just want to wet it with about 10 drops of tap water and put it on the edge of the ISE and store it. You want to make sure that the tip of the electrode is not touching the sponge. So we got really clever about this the last few years, and there's a guard in there that makes it so you do not touch the sponge, but older ones don't have that. So just if it doesn't have it, just make sure that you're not touching the sponge. And we also have videos on how to calibrate the ISEs. So you really don't need to do this before you store them. Calibration for an ISE is only good a couple weeks to a month anyways, if you're storing it. So don't worry about calibrating it right now. When you come back in the fall, or if you use it for a summer research project, take it out, soak it, calibrate it, follow the normal operating procedure for an ISE. And that video right here will show you how to do that. So that is ISEs. All right. Moving right along, unless we have some questions or anything we doing okay, Colleen?
Someone had a good question about with the Go Direct pH probes, if they've aged out, can you just replace the electrode?
Yes. That is one of the reasons I actually recommend the Go Direct over the pH-BTA, because it's much more wallet friendly and much more environmentally friendly without all that electronic waste if you have to throw the whole electrode away or the whole sensor away. So yeah, so this is a BNC connector in the middle here between the amplifier and the electrode. You just take the amplifier off of the electrode. This part gets thrown away or recycled if you have electronics recycling, which hopefully you do. So you're just replacing this part, and we sell these on our website. There is an option if you have a cabled pH sensor to purchase an amplifier separate from the electrode, and then you just have a little cable in between here. That's also an option. So let us know if you want some information about that. But the Go Direct one, I would absolutely recommend. And once the electrode goes bad, or if the bulb breaks, just buy the electrode portion. Save yourself some money.
And I put the link to just the electrode in the chat.
Thank you. Yeah. Excellent. So on to colorimeters. The number one thing we see happening with these is that when people go to store them, they don't look inside and there was a cuvette in there, and then all the solution spills out of the cuvette into the colorimeter, and it's not all waterproof inside there. We've made some changes over the years to make it not as damaging, but especially if it spills out and it sits there all summer, that will ruin your colorimeter. So open those colorimeter lids and check for a cuvette. Take the cuvette out and store it without a cuvette in there. All right. On to dissolved oxygen sensors. This is Colleen's area, so I'm going to pass it off to her.
Fantastic. So dissolved oxygen sensors are pretty easy to store. The big thing is if you have some of the older electrode version that we have here, you want that to actually be stored completely dry. So you want to make sure there's no filling solution left within the tip. And the other thing I like to do is when I'm taking a look at these, I want to make sure I take a good look at the tips, because that's where the actual sensing part is going to take place. So I take a look, and with the optical ones, it's a little more difficult to tell, but usually I see over time they kind of get this kind of gray haze on them and kind of go from black to gray. And that's usually one of my first indicators that it is time for that tip to be replaced. You also can check by just putting it in its storage bottle. So the optical ones have a storage bottle they come with that is very similar to the ISEs, in that you have a little sponge in the bottom, and you want to make sure that that sponge is kept moist. So you want to make sure that that has distilled water, but you don't want the probe sitting in the water. And what it should be reading in that bottle is around 100% saturation. And you don't necessarily have to calibrate it again before storing. What I would just do is maybe check it when you take it out of storage, and make sure it's reading around 100%. If the sponge and the optical DO probe does dry out, it's not the end of the world, which is really kind of nice about this probe, is that a dry sponge isn't going to destroy it. Basically, what I tell people to do is just make sure to get the sponge wet again. And if you have to use the sensor right away, I would go ahead and just soak it in some tap water to kind of basically rehydrate that membrane and get it ready to start reading. Lifetime expectations for the tips, it's going to vary. For the optical DO, our tips are warranted for about 2 years. But I've seen them last much longer than that. And it kind of varies based on usage of how often they're being used. And if they're being used, for example, out in the field, how much abrasive textures that they come up against in like rocks or sand or things like that. And we do have all the replacements for the tips. For the LabQuest version of the optical dissolved oxygen sensor, it involves a tip and a little SD card that you actually have to put into the switch box. For the Go Direct version, you just have to replace the tip, and then there's a little calibration code that you enter in on the back end of the software that we have instructions for on how to do that. And since we're talking about oxygen, let's talk oxygen gas now. So oxygen gas sensors are one of our few sensors that has very specific ways you need to store it. This sensor, you absolutely need to store it upright because there is a electrochemical cell inside of it that if it is stored on its side, that can cause the gel inside the cell to move and actually can give you pretty incorrect readings in there. So what I tend to recommend people to do is go ahead and just store it in the bottle that it comes with, or if you keep the box, keep it in the box and make sure you have it standing upright. The oxygen gas sensor should be reading around 20.9% atmospheric oxygen, depending on your altitude. I should say that does vary. And it's another one of those sensors that's kind of like a pH sensor in that it does kind of have more of a defined lifespan. It's not going to last forever. But what's nice about it is that it is refurbishable. So we can actually replace the cell inside of it and get it up and running functional for you again without you having to buy a whole new sensor. So the way we can tell that is looking at if it's a LabQuest sensor, looking at the live voltage reading, or if it's a Go Direct sensor, looking at the RSR relative stability units. And basically, if the value is below 1.8 volts or below 55 RSRs, then that's a sign that the cell needs replacing. And similar to the pH, I say the cells will last anywhere from 6 to 8 years, depending again on how well they're stored and how they're used. Storing them upright is definitely key and critical. And not only do you need to make sure you store them upright, when you use them, you want to make sure they're being used upright as well. And like I said, once that cell ages out, we can actually do a refurbishment on them so you don't have to buy a whole new sensor. Again, saving costs. And this just gives you kind of a view of what the calibration is going to look like depending on the whether it's a LabQuest sensor or a Go Direct sensor. And I always recommend going outside to calibrate your oxygen gas sensor. Same thing with the CO2. It's best to be in the atmospheric conditions, because when you're inside, there's a lot less air movement and you have a lot more CO2 buildup. So you're not going to have as good of an oxygen reading when you're inside. And so all the sensors we talked about so far are definitely those ones that are very special case scenarios. The big thing to remember is, honestly, most of the sensors don't require any really special storage requirements. Conductivity, salinity, CO2, gas pressure, temperature, soil moisture, drop counters, all of those are literally sensors you could just leave in a drawer or in a bag or a box and they'll be fine. The big thing we always try to make sure people understand is you want to make sure that they are clean before you store them and they are dry if they have any liquid exposure at all. Because any moisture in them can cause damage on these circuit boards internally. And the biggest thing we see is with cabled sensors is if you have the LabQuest versions of the sensors, and I was guilty of this when I was teaching as a student, that it's so tempting just to take that wire and wrap it around the sensor because it's perfectly cylindrical and it just makes sense to do that. That's probably the worst possible thing you can actually do for those sensors, because it can actually cause breakage at the junction point of that wire and eventually causing the electronics inside to fail. So we always recommend doing kind of more of an accordion fold. And what we have found is using Velcro strips, like the kind of Velcro strips that they use to organize cables, and offices and things are great. They work very, very well. And the number one sensor we see this happen on, I would say our temperature sensors are definitely number one, and CO2 sensors, I would say, are number two. And the way you can tell if it's probably a wire breakage is you might move the sensor and you can see the readings will kind of go all over the place. So that's something to keep in mind there, especially. Oh, Melissa. There we go. Clicking on things. The other problem we sometimes get questions on LabQuest sensors is a broken tab on the connector end, the BTA or BTD. Sadly, there's not much you can do to actually repair that. So it's one of those we typically recommend, if you can, get a substance called Subaru. Sorry, I can never pronounce it right. I keep wanting to say Subaru. Subaru, it's kind of this polymer plastic that hardens in air, and we've got a nice, great little video here showing how to fix it yourself. And it's one of those things that this again was a customer said, hey, I found this works really well. So we did a nice little video to show exactly how you can do it. And a lot of times people think that the tab breaking off will break the sensor. It really doesn't. It just makes it so it doesn't fit as nicely into the LabQuest anymore and can get a little loose on its connection. All right, batteries. So batteries are the other big thing we get lots of questions about, especially if you have LabQuest sensors or even anything with a lithium ion battery in it now. The number one thing is do not leave them charging. That's actually could be really, really bad for the battery health and battery life. It's kind of the same concept of with laptops now, how they recommend you not to constantly be charging them all the time. With the Go Direct sensors, we recommend basically if you have a charging station, either unplug the charging station or remove all the sensors from the charging station. And with the Go Direct sensors, you do not need to remove the batteries. The batteries are pretty well sealed inside of there, and it's best if you just kind of leave them be. For LabQuests, very similar. You do not want to leave them charging. For LabQuest 2s, 3s, and for Go Direct SpectroVis Pluses, which also have a LabQuest battery in them, the big things you want to do is you want to make sure that the units are completely powered down, not just asleep. You want to make sure you have them completely shut down. We often recommend with LabQuest and the SpectroVis is to actually completely remove the battery and make sure you disconnect it from charging. The other key thing is make sure if you are at all able to, the batteries are stored in a temperature controlled environment. We've had situations with the lithium batteries that if people have them in classrooms that aren't air conditioned over the summer, and they can get to temperatures well over 90 plus degrees Fahrenheit, that can cause some damage to the batteries. And then you would have to buy whole new batteries the next year. And so a question we get a lot then is, when should I replace my batteries? So we have this great little insider code, is what I like to call it, on our batteries, that if you were to look at the back of the battery, you'll see a 4-digit code. The first 2 digits indicate the week of the year that battery is produced, and the last 2 digits are the year. So the one on the bottom of the screen here was produced the 32nd week of 2013, which says this is a very old battery and definitely needs replacing. Again, kind of like everything else, the battery lifespan is going to vary. The more you take care of them, the longer they're going to last. Usually I recommend is you want to start budgeting for new batteries anywhere between 4 and 6 years, again, depending on your use. You also want to make sure that if the battery starts to swell or puff up at any time, you want to make sure to remove the battery from the unit and look for replacements right away. And also with the lithium ion batteries, they can't be thrown away. So you need to make sure you find a recycling location nearby. Usually a lot of times like Best Buy or other types of electronic stores will take them for recycling. And I'm gonna pass it back to Melissa.
All right, so let's talk about just some general tips and tricks before you leave for the summer so you can save yourself some time in the fall. Software. So making sure that all your software is up to date. We now release about a new version of LabQuest software about once a year. So you want to make sure that your LabQuests are up to date. It helps not only with like sensor identification and making sure you've got all the bug fixes we have, but it also helps with battery regulation and all those other firmware little under the hood goodies that we need to make sure that you have so that your LabQuest 2s and 3s are running latest and greatest. So that is a free update. It is available on our website. And there's all instructions on how to do that update to your LabQuests. when you follow those links and get to the updater. But basically what happens for LabQuest 2s is you download the updater onto your computer, you put it on a USB flash drive, and then you plug it into the LabQuest 2 and the update will start automatically. LabQuest 3, you actually have a little bit of a slicker option and you can update when you're just connected to Wi-Fi if your school allows you to do that. So you can do like an over-the-air update. But you can also do more manual if you don't have access to Wi-Fi or you just prefer that method. GA, so if you are using graphical analysis, spectral analysis, or instrumental analysis, all of those have different release cycles. Graphical analysis gets released pretty regularly. Usually the software itself will show you that it has an update available. We did just release a huge update for graphical analysis. So definitely make sure that you either tell your IT people or whoever is allowed to update graphical analysis on your machines, that you have done that and put in those requests before you come back in the fall. Spectral analysis, we haven't really, I think it was maybe last year, the year before, we released an update. And that was also a pretty nice one. When we release less often, they're usually pretty nice, just in general. So make sure you have the latest spectral analysis as well. And then instrumental analysis, if you have like mini GCs and polar emitters and stuff like that. And spectral analysis is for all of our spectrometers. I forgot to say that, but if you have a SpectroVis Plus, an original SpectroVis, a Go Direct SpectroVis Plus, a UV-Vis, a fluorescence UV-Vis, all of those run on spectral analysis. And if you haven't switched to that, I highly recommend you do. So if you're still using Logger Pro, it is no longer receiving updates. There's some information about that on our website, but we highly recommend thinking about that transition if you're still using Logger Pro. If you haven't looked at graphical analysis in a while, it has like 90% of the features Logger Pro has, if not all of them, and it even has some that are better. I highly recommend spectral analysis over Logger Pro to take data from your spectrometers because it is just much more user-friendly interface. So work on making those transitions, talk to your faculty, talk to your IT people, and start making those changes now so that when you get back in the fall, you don't go to use Logger Pro and it doesn't come up because the operating system on your computer got updated or the USB device is no longer found. Like, it's just causing a lot of issues. So definitely try and make those transitions now. Make sure you have your Vernier account so you can access any software you need and any curriculum you need. Remember that if you purchase a book from us at any point, you have access to that book's resources for a very, very long time, and you get those through your Vernier account. The repair process. So if you think you have a sensor that requires repair, shoot us an email. Be kind of specific. Don't just say my pH probe doesn't work. Tell us what troubleshooting you did. It helps everyone save time and money. And then we'll walk you through how to ship it into us, if there's other troubleshooting we can do, and how to dispose of stuff. So basically contact us. You can email us, you can do chat on our website, and you can call us. Did we have any other questions? Anything else come in? No, we're all good.
Nothing major. Just I had somebody talk about how a student lost the battery cover for their LabQuest 3, and that is definitely something you can just contact us. We'll make sure you get a replacement for that. We definitely have a lot of parts floating around here that we can get you access to.
Yeah.
For sure. And I think the biggest thing is just make sure to contact us. If you have questions, that's really what we're here for. And we have those different methods for you to get a hold of us. So any way that's best for you.
And I forgot to mention it at the beginning of the webinar, but we are giving away a pH storage solution. So we're giving away both a pH buffer capsule kit as well as the pH storage solution. I've gone ahead and entered everyone's name into a random name selector. And our winner today is Alan N. So congratulations, Alan. We will be sending you that pH storage solution. I'm going to go ahead and email you a quick form to fill out so we know where to send it. But congratulations and thank you so much for joining.
And before we go quick, I am going to drop the link to graphical analysis in the chat here. And that will get you to that information. Somebody talked about the difference between if is it included or free. So there is a free version, but there is also a pro version that has some very specific features to it. So the website that I linked in the chat there takes you to the page that will talk about and compare the differences of what you get in basic graphical analysis and the pro version. And what I tell people is pretty much, I would say 90% of what you want to do, you're going to be able to do with the free version, especially for a lot of the more basic classes.
But spectral analysis and instrumental analysis are free. So you just get those directly from our website or from the iOS store, or the Chrome web store, whatever platform you're using. And then I also saw a question about the Logger Pro software for downloading Logger Pro. If you want the latest version of that, odds are you probably have it because we haven't updated it in a while. But if you need that link, go log into your Vernier account on our website, and that will show you all the access you have to your software downloads, so which includes Logger Pro and the curriculum downloads. So if you ever bought like chemistry with Vernier, you should see it there. The accounts are linked by your school, so you don't necessarily have been the one that purchased Logger Pro or purchased the book. We'll see it that your school had it, and typically that happens automatically. If it doesn't, there's a little form at the bottom of that page to request access to the links. Well, thanks everyone for coming, and have a great summer.
Bye, everybody.
Thank you.